4-to-1 exhaust system beginning with the 2013 Mazda CX-5. Let's start by reviewing the design compromises in a conventional exhaust manifold. The peaks in exhaust and intake cycles represent the opening of the exhaust and intake valves. Cylinder 1 is here on top. Cylinder 3, which is next in the firing order, is on the bottom. This hump is the pressure wave shooting down the exhaust port. As you can see, as soon as the exhaust valve opens, there's a big surge of pressure, and that pressure wave races down the runner at the speed of sound. Some of that pressure turns the corner and runs right back up the other runners when it reaches the collector. So here, just when cylinder number 1 is finishing its exhaust stroke, the number 3 exhaust valve opens and is met by a surge of exhaust pressure. That surge arrives at the cylinder number 1's exhaust valve, depending on how fast the engine is spinning and how far the pulse has to travel. With a conventional 4-to-1 manifold, the pulse would land here at 2,000 RPM, here at 4,000 RPM, and here at 8,000 RPM, if the engine could actually run at 8,000 RPM. So, when cylinder number 1 is just finishing pushing the exhaust out, along comes this pressure spike that pushes exhaust back into the cylinder. This dramatically increases the temperature in cylinder number 1, increasing the likelihood of knock. With the activ G421 manifold, the pulse has to travel much farther to get to the number 1 exhaust port. By the time it gets there, even at only 2,000 RPM, the exhaust valve is closed and the pulse can't make it into the combustion chamber. The role of a long exhaust manifold in making power is well known to racing teams and engine tuners. But why don't we see them on production vehicles? Quite simply, cold start emissions. The catalytic converter has to be hot to work properly. Until activ G, the only way to get it hot quickly after a cold start has been to put the catalytic converter as close as possible to the exhaust ports. This is why most vehicles have a short exhaust manifold. The trick to a clean cold start is to get the exhaust gases as hot as possible, as quickly as possible, to get the catalyst up to temperature. activ G heats the exhaust by retarding ignition timing. This causes combustion to happen later in the cycle, so the fuel and air mixture are still burning as it shoots out the exhaust. In a relatively cold combustion chamber, this late combustion is unstable and normally causes misfires. Misfires result in power loss and unburned hydrocarbons. How did Mazda engineers resolve the misfire problem? When the engine is cold, we inject a tiny amount of fuel during the intake stroke. The mixture distributes evenly around the combustion chamber and gives us a lean mixture in most of the chamber. Then, near the end of the compression stroke, we can inject more fuel right at the last second. You'll notice this 6-hole injector spray pattern has one jet of fuel aimed down right into the crater of our volcano top piston, and another aimed high right under the spark plug. This injection pattern, combined with revised timing, gives us a stratified charge, an air-fuel mixture that's rich and easy to ignite around the spark plug, but lean in the rest of the combustion chamber.